Before I begin this video, I'm going to have a disclaimer that the visuals will be tacky. And I'm purely mentioning this because of the fact that in grade 9, you basically called my copper 2 sulfate poster ugly, and I took that to heart. So, disclaimer before you get all rowdy about the visuals in this video. Anyways, moving on to the actual video. Neon. It's commonly known for its use in signs of really stupid quotes or to describe some interesting looking colors, but today I'll be talking about the element itself. The element is in group 18 in period 2 with an atomic number of 10 and atomic mass of 20.180. Neon is an interesting element because it's actually a noble gas, and this tells us a couple of different things. 1. Neon is a gas at 20 degrees Celsius, and 2. Neon naturally has a full valence shell. Looking at periodic trends, the full valence shell tells us that it is extremely difficult for neon to gain as well as lose any electrons, thus giving it little to no electronegativity. Neon is very stable. This makes the first ionization energy incredibly high because it doesn't need any changes to its electron formation. As for the atomic radius, neon has 2 full shells, which will make the atom larger. However, the negative electrons are so attracted to the positive protons that they huddle closer together, and that actually makes the radius smaller. Neon also has a pretty high electron affinity. When it comes to compounds of noble gases, there are a few and far between, almost so little that I contemplate just changing my element, but alas, we're here. So what marvelous neon compound do I present you with? Neon hydrate. Hydrates are essentially just hydrated compounds, and are said to be bonded by hydrogen bonds. H2O is a covalent bond because the elements are both nonmetals, which is also what neon is, and that would technically make the whole compound molecular, but the whole situation is kind of iffy. There's barely any information out there about this compound because, neon doesn't really have compounds. So neon hydrate has a very weak bond, and since it's inorganic, it's also really easy to remove the water. In fact, it's probably more difficult to keep the neon hydrated. Before I move on, neon's compounds are basically theoretical in a way. Scientists believe that neon fluoride may exist, which would be a molecular compound, and that neon should technically have compounds, but there are no known compounds. Neon just hates everyone and everything, and you know what? Good for them, So yeah, now considering that we're basically just discussing watery neon, I'm going to address my next few points as if we were just talking about neon alone. To a person's health, neon is relatively safe. However, too much neon will suffocate you simply because it's a gas and it will replace the oxygen which your body needs. This can be dangerous since neon is odorless and colorless, but this should only be a worry of yours if you work with neon gas, because otherwise neon is quite rare. As for benefits, there's no outright medical ones so far, but there has been research into using neon as radiotherapy for certain cancers, as well as using neon to analyze gases in preparation for lung diffusion tests. As for the environment, neon, being unreactive and like we just discussed, pretty harmless, it doesn't really impact the environment at all. However, usages of neon can be detrimental. Neon signs aren't very environmentally friendly and uses a lot of energy, and they're also not very recyclable. Many people have called on neon sign lovers to instead switch to LED lights as they're much more sustainable, and LED lights are just easier to reuse and they consume significantly less energy. Now, as we've already established, neon is highly unreactive, but I'll be explaining how neon hydrate is formed. This is a synthesis reaction, also known as an addition reaction. This is essentially hydration, so the opposite would be dehydration, which is decomposition or an elimination reaction. This reaction has the reactants of neon and water to create the product of neon hydrate. And here is an example of what the mass of the compound would be if 3.5 moles of neon was used. And that concludes my research project. I hope you enjoyed. It was very difficult to research this element. I don't know why I chose it. That was very stupid of me on my part. But yeah, hope you enjoyed. I don't know if I already said that. Have a good summer, Mr. Hoffman.